Hello.
Hello, sir.
Good morning.
So good morning, all. Now we are live.
Eval video.
Yeah. Good morning to all, dear ladies and gentlemen, esteemed guests, and valued participants. I warmly welcome each one of you for today's webinar. I am Dr. Rahul Pratap Singh, co-convener and associate professor in the Department of Pharmaceutics at the School of Medical Allied Sciences, GD Goenka University, Sona, Gurugram, Haryana. I have come together virtually to explore and discuss the webinar as entitled Solids shall be alternate source to replace harmful organic solvent in future. It is a mixed solvency concept. It's our 24th webinar being hosted by the Society of Pharmaceutical Science and Research under the mentorship of Dr. Sasi Alok, National President, SPSR and Assistant Professor, Institute of Pharmacy, Bundelkhand University, Jhansi, India. Our aim to ensure the healthy life and promote well-being for all at all ages. The objective of the society is very clear. It stands to hold conferences for promoting the causes of profession of pharmacy, to contribute to programs and services to emphasize the health needs of India and the prevention of diseases. It will also work in the field to honor eminent pharmacists, engage in the encouragement of pharmacy education, and to promote and facilitate the acquisition, dissemination, and exchange of pharmacy knowledge and information about the practice of pharmacy and pharmaceutical services. Throughout this wonderful event, we are honored to have incredible speaker, Professor R.K. Maheshwari sir from the Department of Pharmacy at Sri GS Institute of Technology and Science, Indore. We are also joined by our respected Mrs. Monica Sabharwal ma'am as a convener, National Secretary of the Society of Pharmaceutical Science and Research, SPSR, and Managing Editor of the International Journal of Pharmaceutical Science and Research and IJP. Additionally, we have Mr. Ankur Agrawal as co-convener and Associate Professor at Jai Institute of Pharmaceutical Sciences and Research, Gwalior. We all are here to help and guide during the webinar. Without taking much time, I request to Mrs. Monica Sabharwal ma'am to introduce and welcome our guest speaker, Professor R.K. Maheshwari sir, for sharing his experience, expertise, and knowledge on the theme. Most welcome, ma'am.
Thank you so much, Dr. Rahul.
Thank you.
Good morning to all. Myself, Monica Sabharwal, National Secretary, SPSR. A very warm welcome to all of you to this momentous occasion, the inaugural webinar of Solid shall be the alternate source to replace the harmful organic solvent in future, organized by the Society of Pharmaceutical Sciences and Research. It is a truly pleasure to see such an overwhelming response with over 3,000 registrations pouring in from more than 25 countries around the globe. This is a remarkable level of participation, is a testament to the collective eagerness and commitment we share towards the pursuit of knowledge and growth. Today, we gather here as a diverse community of professionals and scholars united by our common desire to explore the new frontiers, exchange ideas, and foster meaningful connections. The power of technology has brought us together, transcending the geographical boundaries and enabling us to connect and learn from one another in ways we could not have imagined before. I would like to extend a special word for the appreciation to our esteemed guest speaker, Dr. R.K. Maheshwari, Professor, Department of Pharmacy, SGSITS, Indore, who has graciously accepted our invitation to share their invaluable insights and expertise with us. Dr. R.K. Maheshwari, your accomplishments and contribution in your field have left an indelible mark, and we are honored to have you here. We eagerly anticipate the wisdom you will impart and inspiration you will stir within all of us. In this rapidly evolving world, the knowledge has become the cornerstone of the progress. It is through the continuous learning and collaboration that we can adapt, innovate, and shape the better future. This webinar serves as a platform for all of us to engage in a meaningful dialogue, to challenge the conventional thinking and to explore the emerging trends and opportunities that lie before us. I would also like to thank my heartfelt gratitude to the National President, Dr. Shashi Alok, Organizing Committee member, Dr. Rahul Pratap Singh, Dr. Ankur Agarwal, Dr. Saurabh Kose, Dr. Sanjay Nagdev, and the dedicated team behind the scene, whose hard work and dedication have made this webinar possible. Their commitment to foster a vibrant learning environment has been instrumental in creating this remarkable gathering. As we embark this exciting journey together, let us embrace the spirit of curiosity, open-mindedness, and collaboration. May this webinar will be the catalyst for a new ideas, a platform for the meaningful discussions, and the source of inspiration with all of us. Once again, I extend my warmest welcome to each and every one of you. Thank you for joining us today, and I wish you to all the rewarding experience. Thank you. Over to the Dr. Rahul Pratap Singh.
Thank you so much, ma'am, for giving a wonderful introduction and achievement of the SPSR Society. And you have included every 360 moment of our achievement and toward the pharmaceutical profession. And now, thank you so much, ma'am, for allowing to conduct this webinar. Let's start with the brief introduction of Professor R.K. Maheshwari, sir. Sir is an expert in hydrotropic solubilization, mixed hydrotropy solubilization, mixed solvency concept, and eco-friendly method in analysis and formulation. With 30 years of vast experience in the teaching, research, and industrial exposure, he has supervised more than 80 M.Pharm projects and successfully guided 2 PhD scholars, with one currently pursuing their doctorate under his guidance. Sir has published more than 190 research articles in peer-reviewed internationally recognized journal with good impact factor. Additionally, he has filed 4 patents and has participated in more than 150 conferences, either as a speaker or attendee. For his exceptional contribution, he has received dozens of awards and recognized at various reputed platforms. Remarkably, he has delivered more than 300 lectures, showcasing his commitment to knowledge dissemination. In this event, sir will be sharing his expertise, insight, and knowledge on the subject. In contest, it is our great pleasure to have more than 3,000 registered participants across the world in approx 21 countries. Our maximum participations are from Algeria, Bangladesh, Egypt, Eritrea, Ethiopia, Indonesia, Iran, Iraq, Macedonia, Mexico, Nepal, Nigeria, Pakistan, Philippines, Saudi Arabia, Sri Lanka, Thailand, Ukraine, Yemen, Zambia, including India. We are overwhelmed to express our gratitude for their participation. Thank you all for joining us today. I encourage all participants to actively engage in discussion, ask questions, and share your experience and knowledge. Together, we can foster a collaboration and innovative environment to explore the full potential of mixed solvency and its role in shaping a greener and more sustainable future. Once again, thank you all for joining us today. Let's make this one event an insightful and enriching experience for everyone involved. Before starting the lecture of sir, we will highlight the topics which sir have explored, and this is very important topic in nowadays. Indeed, the concept of using solid as alternative sources to replace harmful organic solvent in the various applications is a promising approach to address the environment of health concern associated with the traditional solvent uses. Its concept often referred as a mixed co-solvency. Sorry for disturbance. The concept is often referred as a mixed co-solvency or green solvent. It is used of organized solvents in industry such as chemical synthesis, pharmaceuticals, coating, and cleaning agent has been linked to the several issues, including volatile organic compound, emission, air pollution, health risk to worker, and generation of hazardous waste. As a result, there has been a growing interest in the finding sustainable eco-friendly alternatives. The mixed co-solvency concept process is used to solid solvents or solid mixture to enhance the solubility and reactivity of reactant in the process. The main advantage of the approaches are lower environmental impact, reduced waste generation, safer working condition, and enhance the process efficiently. While the concept of mixed solvency soon great promises, it's important to consider factors like availability, cost, and scalability of the solid solvent various application. We have our esteemed guest speaker, Professor R.K. Maheshwari, sir, with us. So welcome, sir. Kindly I request to share your PowerPoint presentation and talk.
Good morning to all of you. Firstly, I would like to thank Dr. Sasi Alok, Dr. Ankur Agrawal, Dr. Rahulji and all the team members who have organized this nice lecture. What you shall get in my lecture, let me explain. Firstly, you will find some new things in my lecture, and that is that each and every thing present in this universe has got solubilizing power. Each and everything means whether the thing is gas, the thing is liquid, or thing is solid. All molecules, in other words, possess solubilizing power. And particularly in my lecture, you will find the utilization of solubilizing power of solids, safe and economic solids, so that we can minimize the use of harmful organic solvents. As soon as some doubt comes to your mind during my lecture, please note down. At the end of the lecture, we will have question and answer session. So I'm going to start my PowerPoint presentation, but as soon as it is going to be started, meanwhile, let me explain some of the things that up to this time, whatever we know from the books and all, that whatever the substances exist in liquid state, they all are known as solvents. For example, water, ethanol, methanol, chloroform, acetone, etc. But there is no solvent which is universal solvent. In other words, we can say whatever the name of any solvent you take, that solvent possesses good solubilizing power for some solutes and bad solubilizing power for other solutes. This statement we have to remember to understand my lecture. What I have told you, that whatever the name of any solvent you take, that solvent possesses good solubilizing power for some solutes and bad solubilizing power for other solutes. For example, we know that water is good solvent for about 1/3 drugs, they are water soluble. Water is poor solvent for about 2/3 drugs, they are insoluble type of drugs in water. So similarly, when I will discuss about the solubilizing power of gases and solids, then in those molecules of gases and molecules of solids, when they are in liquid state, these molecules also possess solubilizing power, but only thing will be, whatever the name of any gas or solid we take, that's molecules of that gas or solid possesses good solubilizing power for some solutes and bad solubilizing power for other solutes. So let me start my PowerPoint presentation. So the topic is more or less means solids shall replace harmful organic solvents in future using mixed solvency concept. Let us understand where we use these organic solvents. So various organic solvents are employed in various analytical techniques, TLC, HPLC, UV analysis, titrimedia, etc. Also, organic solvents are involved in the extraction of active constituents from herbal powders, in the synthesis of organic compounds, in formulation of pharmaceutical dosage forms, in identification, test, etc. Okay, so now drawbacks of these organic solvents. Organic solvents have numerous adverse effects caused by single exposure, like dermatitis, headache, drowsiness, nausea, irritation, etc. Single exposure means, suppose when we perform some experiments with some volatile organic solvents, then it may cause headache, irritation, etc. These are reversible process. But the long-term exposure causes serious ill effects, such as neurological disorders, chronic renal failure, liver damage, neurosis, mutagenesis disorder, etc. So these are the very hazardous effects of vapors of volatile organic solvents. So particularly means the persons or human beings who are involved in routine practice and day-to-day for months together, years together, then there are serious problems to such human beings. So such problems can be minimized by use of solubilizing power of solids. So I will emphasize on the utilization of solids in my lecture. Organic solvents are costly, as well as their disposal requires a special treatment, which is again a cost involving factor. Three classes of organic solvents are there. Class 1 organic solvents include benzene, carcinogenic, carbon tetrachloride, very hazardous to human health and all that. Class 2 organic solvents, they are relatively safer than class 1, but then also they are very harmful. Commonly employed class 2 organic solvents include acetonitrile, chloroform, toluene, methanol, pyridine, hexane, dimethylformamide, etc. Class 3 organic solvents are safest among these three classes of organic solvents, but then also they are harmful for human being. Commonly employed class 3 organic solvents include acetic acid, acetone, ethanol, ethyl acetate, etc. Future role of solvent character of solids. Solubilizing power of solids shall minimize the use of harmful organic solvents in future. Class 3 organic solvents are relatively safer than class 2 and class 1 organic solvents. We can potentiate the solvent power of class 3 organic solvents by dissolving safe solids in them to replace class 2 and class 1 organic solvents. We can potentiate the solvent power of class 3, which are relatively safer, okay, to act as class 2 or class 1 by use of solubilizing power of solids. What happens in dissolution? Dissolution of a solute in a solvent involves hydrogen bonding and weak van der Waals forces between the molecules of solute and molecules of solvent. For example, suppose we dissolve mannitol in water, we get solution of mannitol in water. In simple mechanism of dissolution, we may say that the dissolution of mannitol in water is as a result of hydrogen bonding at weak van der Waals forces between the molecules of solute means mannitol and molecules of solvent means water. Suppose you are dissolving salicylic acid in ethanol, we get a solution, the result as a result of hydrogen bonding and weak van der Waals forces between the molecules of salicylic acid and molecules of ethanol. So this is a simple mechanism of dissolution. Now, mixed solvency concept, which I have proposed in the year 2009, states that each and every substance, whether the substance is gas, liquid, or solid, present in this universe has got solubilizing power. In other words, you may say that whatever are the number of molecules present in this universe, all possess solubilizing power. But one thing is there, the molecules of gas or molecules of solid, they should be in liquid state so that they can take part in hydrogen bonding at weak van der Waals forces for the dissolution of solutes in solvents like this. So this I will explain in my lecture. Once the molecules of a gas or molecules of a solid come in liquid state, they may also be involved in hydrogen bonding at weak van der Waals forces with the molecules of solute for their dissolution. About solvents, whatever matter exists in liquid state at room temperature is known as solvent. Each liquid or so-called solvent possesses good solubilizing power for some solutes and bad solubilizing power for other solutes. Similarly, each matter, whether liquid, gas, or solid, is known as solubilizer in mixed solvency concept. Molecules of all solids in liquid state and molecules of all gases in liquid state also possess good solubilizing power for some solutes and bad solubilizing power for other solutes. Now, before giving the examples, how can we say that solids have got solubilizing power? Let me give some examples of gases. How can we say that all gases possess solubilizing power? So we know supercritical flow technology, in which CO2 gas is compressed and at a particular temperature and pressure, it is liquefied, and then it is used as solvent to carry out different functions. So we ultimately, what is happening here, CO2, when it is compressed at a particular pressure and temperature, it liquefies, and in liquefied condition, the molecules of CO2 are available in liquid state, which may be involved in hydrogen bonding and weak van der Waals forces with the molecules of solutes. For example, when we prepare the nanoparticles using supercritical flow technology, drug molecules, they are dissolved with the help of these liquid molecules, or the molecules of CO2 in liquid state like this. So many things are there. So, but since it is a cost involving, you may say it is costlier affair, so we are keeping them aside, but all gases possess solubilizing power. Main thing is now, which we should utilize economically as well as safely, they are solids. So firstly, I will give the examples. How can we say that solids have got solubilizing power? And then I will give the application part. So when I give the examples of solid solubilizing power, please do not relate with formulation. I will tell you later on that how can we apply the solubilizing power of solids to replace harmful organic solvent. Now, there are three ways by which the molecules of a solid may come in liquid state, so that these molecules can be involved in hydrogen bonding weak bonding forces with the molecules of solutes for their dissolution. So there are three ways. Number one is by melting, number two by dissolution in a solvent, number three by eutectic formation. So firstly, the examples of melting. Suppose we take 1 gram urea in test tube and heat it on heating metal at 132 degrees centigrade, which is the melting point of urea. We get a clear colorless melted urea liquid, which is shaken like any liquid. Okay, now in this 1 gram of dichlorphenate sodium is nicely dissolved. 1 gram melted urea, 1 gram dichlorphenate sodium at 132 degrees centigrade. Why it is happening? Because of solubilizing power of urea molecules, because urea molecules have come in liquid state, and these molecules of urea are involved in hydrogen bonding and weak bonding forces with the molecules of dichlorphenate sodium. That's why we are getting a clear solution of 1 gram dichlorphenate sodium and 1 gram melted urea. Melting point of dichlorphenate sodium is 283 degrees centigrade, which is quite higher. So we should not think that dichlorphenate sodium might have melted. It has not melted. Now you see, suppose there was no solubilizing power in urea molecules, then we could have obtained a suspension. Okay, so this is an example that by melting the molecules of urea, they are coming in liquid state for to demonstrate their solubilizing power due to hydrogen bonding weak bonding forces with the molecules of dichlorphenate sodium. We are not making any formulation, please mind it well. Number two example is that of phenol. 1 gram phenol in your test tube, water bath, melting point 44 degrees centigrade, you will have 1 gram clear colorless melted phenol liquid, which can be shaken like this, liquid by any liquid. In this, there is very nice solubility of nalidixic acid, about 500 milligram per gram of melted phenol liquid at 44 degrees centigrade. Nalidixic acid is a poorly water soluble drug. Why we are getting very good solubility, 5% soluble, about 50% solubility is there, 500 milligram per gram. Means the reason for this is the molecules of phenol are available in liquid state at 44 degrees centigrade and melted condition, and these molecules of phenol take part in hydrogen bonding forces with the molecules of nalidixic acid, and we get a large solubility of nalidixic acid in melted phenol. So this, what does it indicate? That molecules have got solubilizing power for nalidixic acid, which is a poorly water soluble drug. We are not making any formulation, but it is a proof that solids have got solubilizing. Another way by which the molecules of a solid may come in liquid state is by dissolution in a solvent. So I will give examples of 3 solvents. Number one, water at room temperature. The solubility of ibuprofen in water is 0.028% weight by volume. Very poor solubility of ibuprofen in water at room temperature. The reason for poor solubility is due to limited extent of hydrogen bonding and weak van der Waals forces between the molecules of ibuprofen and molecules of water. But when we use a concentrated solution of sodium benzoate, 28.8% weight by volume, 28.8%. So in this concentrated solution of sodium benzoate, the solubility of ibuprofen is 2.390%, 2.390% weight by volume. About 85-fold solubility enhancement is there. What is the reason for solubility enhancement? The molecules of sodium benzoate, they are in liquid state in solution, and these molecules of sodium benzoate are involved in hydrogen bonding and weak van der Waals forces with the molecules of ibuprofen. That's why we get large solubility of ibuprofen in concentrated solution of sodium benzoate. So here, what we are getting is solid sodium benzoate. When it is dissolved in a solvent like water, it is giving solubilizing power. I mean, solid possess solubilizing power. Another solvent, ethanol. Furosemide, poor solubility in ethanol, 1.7%, sparingly soluble due to limited extent of hydrogen bonding, etc. Like this. Now, when we dissolve 15%, when we prepare a solution containing 15% weight by volume of niacinamide and ethanol, in this solution, the solubility of furosemide is about 5%. So 5 divided by 1.7, 3-fold enhancement in solubility there at room temperature. What is the reason for enhancement in solubility? The reason is the molecules of niacinamide, which is solid, at room temperature. When it is dissolved in ethanol, the molecules come in liquid state, and these molecules of niacinamide, they take part in hydrogen bonding and weak bonding forces with the molecules of ibuprofen, this furosemide to get large solubility. So again, here there is proof that solid possesses solubilizing power. Third example, propylene glycol solvent. At room temperature, the solubility of pyroxicam is very poor in this propylene glycol, about 5 milligram per ml, poor solubility. But when we prepare a solution containing two solids, 10% sodium acetate, 10% sodium caprylate, 20% total strength. So all these molecules of sodium acetate and sodium caprylate, they are in liquid state. And in this solution, the solubility of pyroxicam is about 120 divided by 5, about 24-fold enhancement in solubility there. The reason for solubility enhancement is same. These two solids, when their molecules, they come in liquid state in propylene glycol solution, then these molecules are involved in hydrogen bonding and weak bonding forces with the molecules of pyroxicam for solubility enhancement for its dissolution and all that. So these were all were the proof. Now we shall discuss by which the molecules of a solid may come in liquid state is by eutectic formation or eutectic mixture. How? Suppose we take 5 gram thiamol, 5 gram menthol, trisurate with the help of pitch and mortar, we get a clear, colorless eutectic liquid containing these two solids. Means molecules of these two solids will be in liquid state. So this solvent system, or you may say this liquid is there, and the pH of this liquid is 6.5, which is nearly neutral. Now the properties of this eutectic liquid containing two solids, thiamol and menthol, if you take 1 ml of this eutectic liquid, it nicely dissolves for about 200 milligram of metronidazole benzoate. Means about 20% solubility of metronidazole benzoate in this eutectic liquid. What is the reason here? Otherwise, this metronidazole benzoate is a poorly water-soluble drug, but here the solubility is about 20%, very nice solubility. The reason is we are not making formulation, but what we are observing that these molecules of thiamol and menthol, they are in liquid state in this eutectic liquid, and these molecules of thiamol, menthol, they are involved in hydrogen bonding and weak bonding forces with the molecules of metronidazole benzoate for its dissolution. Similarly, the remaining ethanol or arnidazole, benzocaine, etc., they all have got good solubility in this eutectic liquid. We are not discussing about the formulation. Right hand column, you see cetronidazole. 1 ml of this eutectic liquid does not dissolve even 5 milligram of this cetronidazole. So for cetronidazole, this eutectic liquid is a bad solvent. Similarly, furosemide, nimesulide, aspartame, for all these compounds, this eutectic liquid is a bad solvent. Now, if you see the miscibility or solubility of liquids, ethanol, propylene glycol, benzyl alcohol, etc., they have got good miscibility or solubility in this eutectic liquid, but glycerine, immiscible in this, insoluble in this, water, insoluble in this. Okay. Similarly, if you check thousands of compound, hundreds of compounds, some will fall in this category for their solubility, some will fall in this category. So now you may say this eutectic liquid is good solvent for some solutes and bad solvent for other solutes. This means this eutectic liquid is a solvent. And once it is proved that it is a solvent, it means whatever it contains molecules of two solids, thiamol, menthol, they must possess solubilizing power. That's why this liquid is behaving like solvent. So these all were the proof that solids have got solubilizing power. Coming to hydrotropic solubilization now. Working this hydrotropic solubilization, I have come to develop this mixed solvency concept and all that. And what is this hydrotropic solubilization, which is about more than 100 years old concept. Hydrotropic solubilization is more than 100 years old concept, but I have started its use to minimize the harmful organic solvent. So before application part, let me explain what is this hydrotropic solubilization. As you know, the word hydro means water. So this hydrotropic solubilization relates with solubility enhancement in aqueous solution or in water. Not in other solvents, no, only in water or in aqueous solutions. Now, examples of this hydrotropic solubilization, in the middle of this table, you see urea. 60% weight by volume solution of urea and water, a concentrated solution of urea and water. This is very good solvent for dichlorophenolic sodium. The solubility of dichlorophenolic sodium in this 60% weight by volume solution of urea and water is at room temperature is about 4.8%. 4.8%. But the solubility of dichloronic sodium in water at room temperature is about 1.6%, 1.6. So 4.8 divided by 1.6, threefold enhancement in solubility is there. So what is the reason for solubility enhancement? The molecules of urea are present in liquid state in urea solution, and these molecules of urea are helping to dissolve dichloronic sodium due to hydrogen bonding and weak van der Waals forces. And this is, of course, an example of hydrotropic solubilization. Hydro means aqueous solubility enhancement. In aqueous solution of urea, the solubility of dichloronic sodium is being enhanced. Another example, left-hand side, sodium citrate. If you prepare 45% strong solution of sodium citrate in water, in this concentrated solution of sodium citrate, the solubility of salicylic acid is more than 15%, more than 15%. Otherwise, in water at room temperature, the solubility is 0.3%, nearly 0.3%. So 15 divided by 0.3, about 50-fold enhancement in solubility is there. The reason, and of course, this is hydrotropic solubilization, because in aqueous solution of sodium citrate, the solubility is being enhanced. So here the reason is sodium citrate molecules, the molecules of a solid sodium citrate, they are available in liquid state for hydrogen bonding and weak van der Waals forces with the molecules of salicylic acid. That's why you are getting a lot solubility. Now, another example we may take from left side, sodium benzoate. If you prepare 30% weight by volume solution of sodium benzoate in water, a concentrated solution. In this concentrated solution of sodium benzoate, the poorly water soluble drugs is enhanced, like that of ofloxacin, gatifloxacin, tindazole, metronidazole, neridixic acid, hydrochlorothiazide, ketoprofen, flurbiprofen, ibuprofen, atenolol, paracetamol, etc., etc. So this sodium benzoate solution concentrated is very good solvent for this poorly water soluble drug. These all are the examples of hydrotropic solubilization. Now the definition of this 100-year-old concept, hydrotropic solubilization, when there is enhancement in aqueous solubility of a poorly water soluble drug in the presence of a large concentration of an agent, means these hydrotropic, then we call this phenomena to be hydrotropic solubilization phenomena. Now I will give the application part, that how can we utilize the solubilizing power of solids to replace harmful organic solvent. So firstly, I will discuss eco-friendly titrimetric analysis of poorly water soluble drugs using hydrotropic solution without using organic solvent. Poorly water soluble drugs, they require organic solvent for their dissolution for titrimetric analysis. So first you see the example of fusamide API, active pharmaceutical ingredient as per Indian Pharmacopoeia 2022, as well as that of British Pharmacopoeia. The method is same, and that method is weigh accurately about 0.5 gram fusamide API, dissolve in 40 ml of dimethyl formamide. So you will get a clear solution, and this DMF is a dimethyl formamide is a class 2 organic solvent. You are getting clear solution. Now few drops of bromothiamine blue indicator is added, and titration is performed with 0.1 molar NaOH solution. So suppose the reading at end point is x1 ml, okay, of NaOH solution. Now then carry out the blank determination. In blank determination, you will take another neat and clean conical flask. You will take 40 ml of dimethyl formamide, in that few drops of bromothiamine blue indicator. You will titrate with the help of NaOH for endpoint. Very few ml of NaOH will be required for color change of this indicator. Suppose that reading is Y1 ml. So this Y1 ml is due to solvent only. So this will be subtracted from X1. So X1 minus Y1, this much volume of NaOH has been consumed for your drug, using the factor given in this at the last 1 ml of 0.1 molar NaOH is equivalent to 33.07 milligram of fusamide. Using this factor, you can calculate the percent purity of this active pharmaceutical ingredient. What is the what they are using in pharmacopoeia method? They are using dimethyl formamide, which is a class 2 organic solvent. Means harmful organic solvent, means the volatility, means vapors of dimethyl formamide will give harm to the human being who is performing this test, like this. So okay, now why they have used dimethyl formamide, why they have not used ethanol? Ethanol is a better class 3 organic solvent than dimethyl formamide. but they have not used because of poor solubility or sparingly soluble fusamide 1.7%. So ethanol could not be employed by Pharmacopoeia. Otherwise, suppose there was good solubility in ethanol, then they could have preferred ethanol before choosing this dimethyl formamide. Now I will tell you one method here. How can you potentiate the solvent power of this class 3 organic solvent to act like a class 2 like dimethyl formamide? I have showed you that 15% weight by volume solution of niacinamide in ethanol has got 5% solubility of this fusamide. Means 5% means is soluble category. So now in place of dimethyl formamide, if you take 40 ml of 15% weight by volume solution of niacinamide in ethanol, now this is a strong solvent, it will dissolve your drug, then you will perform the titration and blank determination will be carried out and all these things will be done. Now, in this way, you can potentiate the solvent power of a class 3 organic solvent like ethanol to act as class 2 solvent like dimethyl formamide, so that you can minimize the harmful effect of vapors of such organic solvents. Okay, so in this way, you are seeing that solubilizing power of a solid niacinamide, it does not evaporate out. It will help in the dissolution of your drug for its titration analysis. So there will be no need of dimethyl formamide. Like this, in this way, you can minimize the harmful effect of organic solvent like this. Now, still better than this is hydrotropic solubilization. Now I am discussing this green chemistry method, hydrotropic analysis. Weigh accurately about 0.5 gram fusamide API. Dissolve in 40 ml of 30% weight by volume sodium benzoate aqueous solution, hydrotropic solution. You will get a clear solution due to hydrotropic solubilization, or in other words, you may say because of solubilizing power of this solid sodium benzoate, you are getting clear solution. Few drops of bromothiamyl blue indicator will be added, and you will run 0.1 molar NaOH for titration. Suppose the reading endpoint, at endpoint the reading is x2 ml of NaOH solution. Then you will carry out a blank determination, another neat and clean conical flask, 40 ml of 30% weight by volume solution of sodium benzoate, few drops bromothiamyl blue indicator, 0.1 molar NaOH. Few ml will be required for endpoint. Suppose the reading is Y2 ml. This Y2 ml has been consumed by sodium benzoate solution. So here also it might have been, it has been consumed. So X2 minus Y2, this much volume of NaOH has been required for your drug using the same factor of Pharmacopoeia. 1 ml of 0.1 molar NaOH is equivalent to 33.07 milligram of fusamide. You can find out the percent purity of your API. Now, the beauty of this method, hydrotropic method, is that number one, sodium benzoate solution 30%, its cost is about ₹40, Indian currency, ₹40 per liter. But the cost of, you say, dimethyl formamide, etc., or methanol, chloroform, etc., is nearly ₹200 or 200 or 300 rupees per liter. Indian currency, I am talking about like this. So, our method is economic. But main thing is this sodium benzoate is not volatile. It does not evaporate out. It will not go in your body. No. But so what you are doing, you are replacing dimethyl formamide, which is a class 2 harmful organic solvent, by utilizing aqueous solution of sodium benzoate. Means you are utilizing the solubilizing power of solid to replace a harmful organic solvent like this. Now, similarly, now flurbiprofen API IP 2022 requires ethanol for its dissolution. Ethanol has been replaced by sodium benzoate in the same way as we have discussed about the fusamide. Naproxen API assay utilizes methanol in Pharmacopoeia method, class 2 organic solvent. Methanol has been replaced by sodium benzoate solution in the same way, means without organic solvent. Salicylic acid involves use of ethanol, class 3 organic solvent. Ethanol has been replaced by sodium citrate solution. It is another hydrotropic solubilizing agent. Its cost is also nearly ₹40 per liter, and it is non-volatile, and all these things are there. Ketoprofen, ethanol is used. Sodium benzoate has replaced this ethanol. Ibuprofen ethanol has been replaced by a sodium benzoate solution. Now, as far as the assay of ibuprofen tablets is concerned, as per Indian Pharmacopoeia 2022 or BP, the same procedure is there. Weigh and powder 20 tablets. Weigh accurately the powder equivalent to 0.5 gram of ibuprofen. Extraction is done with chloroform in pharmaceutical method. Then chloroformic extract. From this, the chloroform is evaporated out. Semi-solid residue is then dissolved in ethanol 100 ml and phenolphthalein few drops added, and titration with NaOH and carry out the blank determination. So here there is involvement of 2 organic solvent, chloroform class 2 and ethanol class 3 organic solvent. Now these both organic solvents have been replaced by hydrotropic solubilization technique. What you have to do, weigh the tablet powder equivalent to 0.5 gram of ibuprofen. You have to shake it briskly for 10 minutes with 100 ml of 30% sodium benzoate solution. So during this shaking with 100 ml of 30% sodium benzoate solution, the ibuprofen present in the tablet powder goes in solution. Titration with NaOH in presence of phenolphthalein. Blank determination, you can find out the correct, you may say the drug content of your tablets. The beauty of this method is this: there is no involvement of any organic solvent. You are replacing chloroform and ethanol by sodium benzoate solution. So economic as well as it is safe for human being. Similarly, these things can be done. Ethanol, ethyl vanillin, pharmaceutical method, dimethyl formamide can be replaced by hydrotropy. Indomethacin, acetone can be replaced. Glynicylamide ethanol, chlorpropamide ethanol, mefenamic acid ethanol can be replaced by hydrotropy method. After titrimetric analysis, coming to UV spectrophotometric estimations of pharmaceutical doses forms of poorly water soluble drugs using hydrotropic solubilization method. So here, what we are discussing, the solubilizing power of solids, economic and safe solids we are utilizing to replace harmful organic solvent. The example of UV estimation is that of BP method. 2022 IP method is weigh tablet powder equivalent to 0.15 gram of tindazole plus 20 ml of methanol. It is shaken for sufficient time and then volume is made up to 100 ml with methanol. This is pharmaceutical method. Then to remove insoluble tablet excipient, filtration is done. 10 ml of filtrate is diluted to 100 ml with methanol. Then from this 10 ml again it is taken and diluted up to 100 ml with methanol, and the absorbance of this particular solution is noted at 310 nm, 310 nm against methanol reagent blank. Okay, then calculate the content of tindazole taking 356 as the specific absorbance at 310 nm. So this is the pharmaceutical method which is utilizing methanol class 2 organic solvent. Okay, because tindazole is water insoluble drug, so they are using methanol class 2 organic solvent. Now I am replacing this methanol by sodium benzoate solution. How? I mean hydrotropic method. Weigh tablet powder equivalent to 50 milligram of tindazole, add 20 ml of 30% aqueous solution of sodium benzoate and shake it for 20 minutes in a 25 ml volumetric. Again, I am repeating 25 ml volumetric flask. Tablet powder equivalent to 50 milligram of tindazole in your volumetric flask. 20 ml 30% solution of sodium benzoate, shaking for 30 minutes. During this shaking, sodium benzoate dissolves the tindazole present in the tablet powder due to hydrotropic solubilization. Then volume is made up to the mark, means up to 25 ml with water. Then to remove insoluble excipient, filtration is done. 1 ml filtrate diluted up to 100 ml with water. And then this solution is used to note its absorbance. Absorbance of this solution is noted at 318 nm against reagent blank. 318 because here the solvent system is water. So in water, the peak of tindazole comes at 18 nm, but in methanol, the peak was at 310 nm. We know due to change in solvent, there may be shifting of the peak. So there is no problem in this. We are noting its absorbance of the solution at 318 nm against reagent blank. How this reagent blank is made, let me explain from the point of view of a student. You see, reagent blank will be made in this way. You will take a 25 ml volumetric flask, neat and clean, 20 ml of 30% sodium benzoate solution, 25 ml with water, 1 ml from this, diluted up to 100 ml with water. This is the reagent blend. Reagent blend, because this reagent blend solution contains the same amount of sodium benzoate in this, which is present together with the drug in your sample solution. So sample solution is put in the sample cuvette, and this reagent blend is kept in the reference cuvette, and then absorbance is noted at 318 nm. And then you can make its calculation curve using 50 milligram of standard drug, pure drug. In the same way, making 5, 10, 15, 20, 25 mg per ml solutions, and respect to reagent blends, 5 against 5, 10, like this, you can make its calculation curve, and using this calculation curve, you can find out the drug content. Now, two things are important. Number one, your 30% sodium in currency, but other solvents, methanol, etc., they are costlier. Number two, sodium benzoate does not interfere above 292 nm, which is the cutoff point. Means above 292 nm, sodium benzoate does not have its own absorbance. So there is no interference in this UV spectrophotometric analysis of your drug at 318 nm. So you can select any such a drug which has got at least one peak above 292 nm. So in this way, you can carry out the spectrophotometric analysis of poorly water soluble drugs using this hydrotropic solubilization. What we are doing, we are replacing the pharmaceutical method. They are using methanol, class 2 organic solvent. Without any organic solvent, you are able to perform the UV spectrophotometric analysis. Now, suppose you want to estimate, let me go some more example here. Naproxen tablets, UV analysis using hydrotropy using sodium benzoate solution. Methanol has been replaced. Methanol of pharmacopoeia has been replaced by sodium benzoate solution. Here the estimation was done at 331 nm, which is away from 292 nm. Sodium benzoate does not interfere. Indomethacin capsule, methanol of pharmacopoeia has been replaced by sodium benzoate solution, because here estimation is done at 320 nm. Using sodium benzoate solution, no interference of sodium benzoate. Diazepam capsule, methanol has been replaced by mixed hydrotropy. Here the estimation is done at 354 nm. Now, before 292 nm means, for example, if you use urea as hydrotropic agent, urea does not interfere above 240 nm. So in case of atenolol tablets, IP method, BP method, they utilize methanol, atenolol, but urea solution has been employed to replace this methanol. So here in this case of atenolol, the estimation is done at 275 nm. 275 nm is away from 240 nm. That's why there is no UV interference of urea here. Other agents which can be employed above 240 nm are sodium acetate, sodium citrate, sodium caprylate, and so on and so forth. Those who are interested in such all these methods, at the end of the lecture, I will give my WhatsApp number and email ID. Those who want to connect with me or to want to ask some questions in future, they can ask me, no problem. Okay. Now after this, I am coming to TLC. Means TLC of compounds can be performed without the use of any organic solvent. Here, published paper reference is there. This paper, employment of hydrotropic solubilization and mixed hydrotropic solutions as mobile phase to carry out TLC, precluding the use of organic solvent. This published paper is available online on Google search. What has been done here? 9 water-soluble drugs were selected by AM Onward students, the team who has carried out this work. And of course, this work has been applied for Indian patent. And these 9 drugs selected were propanol, hydrochloride, guaifenesin, up to this low sartan potassium. 9 water-soluble drugs were selected. Now, for each drug, 2% aqueous solution was prepared to make the spot on the silica gel plate. After putting making the spot was dried in at about 60-70 degrees centigrade for the removal of water. Then these TLC plates, they were developed using different hydrotropic solutions or mixed hydrotropic solutions. How it was done? Now you may see, you may see the blends. 8 blends were used by student. Blend 1, aqueous blend, no organic solvent, 5% sodium benzoate, 5% sodium acid. Only 2 solids were there in solution, no any other solvent. And this solution was used to develop the TLC plate. After development of the plate, the plates were dried at about 60-70 degrees centigrade for removal of water. And then the spot identification was done in iodine chamber. I told the students that they will use 8 blends for each drug, and the blends which give good spot without tailing effect shall be selected for your drug. So like this, what they have selected, you see another blend 2, sodium benzoate plus niacinamide. Third blend, sodium benzoate plus sodium citrate, like this. Without organic solvent, we are performing this. Now for propanol hydrochloride, this 8th blend, 7.5% niacinamide and 7.5% sodium benzoate. No any organic solvent, gave good RF value 0.8 without tailing effect. Other 7 blends were not suitable for them. Guaifenesin drug, blend 1, 2, 3, 4, and 7, they were selected because they gave a spot without tailing effect like this. So in this way, what you are seeing that without any organic solvent, you are able to perform the TLC. Now, I will give some example. Here, the pharmaceutical method of ciprofloxacin hydrochloride. It uses dichloromethane, class 2 organic solvent, methanol, class 2, acetonitrile, class 2. Always up to this time, whatever the TLC you will see from any published paper or from any books, always 1, 2, 3, like these organic solvents. Each and every compound, if water compound is water soluble, small concentrations of hydrotropic agent or mixed hydrotropic agent. Otherwise, if your drug is water insoluble type of drug, then you will have to use higher concentration of hydrotropic solutions or mixed hydrotropic solution, maybe 25%, 30% like this. Because here in TLC, there are 3 phenomena: solubility, adsorption, and partitioning. So solubility is one of the factor. So for solubility, as you are okay, I'm sorry. Now, is it okay, na? Chal raha hai? Yeah. Okay. So up to this, what I am saying you that for each and every compound, we can use this TLC. Okay. Now, those who are interested, I will at the end of the lecture, I will more information about this TLC. Now, coming to reverse phase HPLC, this work has been done by Remy SL Madam. Published paper reference is there. In particular, this project, what has been done, cefixime tablets have been analyzed by Remy Madam by reverse phase HPLC. What she has implied as mobile phase, 6% weight by volume aqueous solution of sodium acetate. After adjusting its pH to 6.2 with acetic acid, there was no methanol, no acetonitrile, no organic solvent in this particular blend. And this paper you can see it is available on PDF is available online. Okay. Now, another work which Remy Madam has done is a novel eco-friendly cost-effective mobile phase for HPLC simultaneous estimation and validation of paracetamol and diclofenac sodium in bulk and pharmaceutical formulation by reverse phase HPLC using hydrotropic solution as mobile phase. Now you see this published paper reference is there. What mobile phase says use 5% urea solution. So this solution was used as mobile phase without any organic solvent. Now you listen one sentence from me. For each and every water soluble compound, you can perform a reverse phase HPLC using smaller concentrations of hydrotropic agents as mobile phase. But for insoluble drug, you do not try because there are limitations for insoluble type of drugs. Now, mixed hydrotropy. I told you that hydrotropic solubilization is more than 100 years old concept, but no one has started mixed hydrotropy before 2008. We have started this mixed hydrotropic solubilization and what is that and why it is used. You see, up to this time, from 100 years, so many persons, they have developed so many formulations using large concentration of hydrotropic agent, but such concentrations of hydrotropic agent, they are not advisable, they cannot be used, and that's why the formulations could not be marketed. Now I will tell you how can you market your formulation using mixed hydrotropic solubilization. You see, mixed hydrotropic solubilization means if you can employ a smaller concentration, safe concentrations, but a smaller concentration of hydrotropic is in making a concentrated solution to develop some formulation, then definitely you can market it. Now how? I will give this example with this particular table, and this table is has been obtained from a book known as Inactive Ingredient Guidebook 2019. This book is a thick book. It gives the different, you may say, the concentrations of additives which can be employed in different formulation. So for you, I have brought this list for aqueous intramuscular injection, means additives which are employed in such concentrations, they are safe concentrations to make aqueous intramuscular injection. For example, you are seeing alcohol 10%, no problem in aqueous intramuscular injection. Or sodium citrate 10%, no problem, like this. So this is a small list of containing 19 additives, and for 17, 18, and 19, they are 5%, others are 10%. Now, you see how the mixed hydrotropic solubilization can be used to make marketable formulation. You see, 30% sodium benzoate solution. If you have made a aqueous intramuscular injection, it cannot be marketed because it contains a large concentration, which is not being permitted in as per Inactive Ingredient Guide. But suppose you, in place of 30% sodium benzoate, if you take, say, number, you see 13 number sodium benzoate, 10%. Then you see number 8, sodium acetate, 10%. Number 2, sodium citrate, 10%. So these 3 ingredients, they are safe in aqueous intramuscular injection, 10% sodium acetate, 10% sodium citrate, 10% sodium benzoate, making a concentrated solution 30%. In this solution, when the drug solubility is enhanced sufficiently, you can develop aqueous intramuscular injection of that drug. So in this way, mixed hydrotropic solubilization can solve the problem of this toxicity issue, and you can make marketable formulation. Now, another thing which I will explain through the same list is second parameter of mixed solvency concept. Mixed solvency concept, there are 2 parameters, which I have started in the year 2009, first time in the world, you may say. First parameter of mixed solvency concept says that each and everything present in this universe has got solubilizing power. Whether the substance is gas, liquid, or solid, all molecules present in this universe have got solubilizing power. All are known as solubilizers, but whatever the name of any solubilizer you take, that solubilizer possesses good solubilizing power for some solutes and bad solubilizing power for other solutes. Second parameter, since each and everything has got solubilizing power, this means whatever the additives we are employing in our formulation, they must also possess solubilizing power for your drugs or for solutes. Okay, the same principle we are going to adopt here, that we will make a concentrated solution using safe concentrations of different additives, making a concentrated solution. When the solubility of a drug is enhanced sufficiently, we can make it aqueous intramuscular injection, because this list is for additives for aqueous intramuscular injection. So now you see, you can make innumerable safe solvent system using this small table. Now you see number 1, 2, 3, ethanol 10%, sodium citrate 10%, arginine 10%. If you make a blend, this is one mixed solvent blend. If you change arginine by histidine, another blend is ready. So by permutation combination, altering the different concentrations of these safe additives, sometimes you can imply 5%, sometimes you can use 4, sometimes 5 additives like this. You can make innumerable safe solvent system for what? To develop the aqueous intramuscular injection, because you are implying these additives in safe concentration, and the solubilizing power of these additives will be employed to enhance the solubility of your poorly water soluble drug. Similarly, you can make use of this mixed solvency concept to develop, you may say, in syrups and ready-made injections and all that like that. Okay, now coming to the reaching there again, this mixed hydrotropy. So please, I am leaving this because I think you have understood this. Now another example of mixed solvent system, parameter 2. that if you make a concentrated solution. So sodium benzoate 5%, caprylate 5, citrate 5, holoxamer 5. Total 20% aqueous solution, pH 7 neutral in this blend, which we will say mixed solvent blend containing 4 solids. Molecules are in liquid state, and this solution and the solubility of several poorly water soluble drugs was checked in the solution. The examples up to I am giving here: furosemide solubility in this particular blend 35 milligram per ml. Otherwise in water, not even 1 milligram per ml. So at least 35-fold solubility enhancement is there, that of furosemide at room temperature. The reason for solubility enhancement, the molecules of all these solids, they are in liquid state, and these molecules are involved in hydrogen bonding. Weak van der Waals forces with the molecule solubility. Now, so what can you do now using this mixed solvency concept? Utilizing the solubilizing power of these solids, you can develop this injection. For example, furosemide tablets in market, 20 milligram per ml tablets are there in market. 20 milligram per ml injection can be made using this mixed solvent blend, because the solubility of furosemide in this is 35 milligram per ml. Another very good application of this is you can utilize this concept to develop dry powder injection for reconstitution of those drugs which are hydrolyzable. You cannot make ready-made injection of hydrolyzable drug. So what you can utilize? You can utilize the solubilizing power of solids at the time of need, after 1 year, 2 years, like that. You will add water, you will get a solution, it will be injected. For example, here, if you see, in place of furosemide, suppose a water-insoluble drug is there, okay, which is hydrolyzable. You cannot make it aqueous injection. Suppose you want to make it 20 milligram per ml injection, and solubility, suppose it is same 35 milligram per ml in this blend. So what can you do? To make 20 milligram per ml injection, you will need 50 milligram of benzoate, sodium benzoate, 50 milligram caprylate, citrate, and all these. So 50, 50, 50, 50, these 200 milligram solid solubilizers are there, or additives are there. 20 milligram drug will be put here, while now after 1 year, 1.5 years, like 2 years, whenever you will add 1 ml water, you will get a clear solution due to solubilizing power of safe solid additives like this. So in this way, this concept is very useful. Now this is the example. Those who are interested, they can see this one. This is M-Pharm project done here in SGSITS. Dry powder injection for reconstitution of poorly water-soluble drug candicertan selexetil for 1 ml injection. And the dose of candicertan selexetil is 8 milligram. In vial, we will put 100 milligram caprylate, benzoate 50 milligrams, acetate 50 milligram, and 8 milligram drug. At the time of need, 1 ml water, reconstitution, you will get clear solution. So those who are interested to get soft copy of such theses, I can send to you, so that step by step you can find out that how to proceed for a particular project to take. Because from published paper alone, it is not possible. Sometimes it is difficult rather to follow the procedure. And of course, published paper reference is there. Those who are interested, they can see this paper. Mixed solvency concept can be used to develop the solid dispersions. I will take only about 10 minutes to finish my lecture. Then there will be question and answer session. Solid dispersion, they can be made. The example is that of M4 project, furosemide insoluble drug, sodium citrate. These are the carriers, water soluble carrier, acetate, beta cyclodex, and caprylate. In minimum quantity of water, these sodium citrate, sodium acetate, so beta cyclodextrin, sodium caprylate, they have been dissolved, and because of solubilizing power of these solids, furosemide will get clear solution in this. Water will be evaporated out on magnetic string, heating on water bath and all that. And when semi-solid is left, it is dried in oven, and then it is sifted through fine sieve. So this is the solid dispersion. It will go fast to solution. So this M-Pharm thesis is on this. Liquid solid system can be developed using the solvency concept. You see here the example is that of one M-Pharm project. The solubility of pyroxychem in propylene glycol, which is non-aqueous solvent selected for liquid solid system, is very poor, 5 milligram per ml. But when 2 solids were dissolved in this propylene glycol, 10% sodium caprylate, 10% sodium acetate, molecules are in liquid state, they have increased the solubility to the extent 120 milligram per ml. So now you see, suppose the solubility at room temperature in propylene glycol alone, it is 5 milligram per ml. So for 20 milligram, which is the dose of pyroxychem, you will require 4 ml of propylene glycol per gram. To make it free flowing, you will require about 10-12 gram of adsorbent. So you cannot make it's a tablet or capsule. But if you potentiate the solubility due to solubilizing power of solids, you can make. How the student has done, used this solution containing 2 solids. The solubility is 120 milligram per ml. So you may assume it to be 100 milligram per ml. 100 milligram per ml, 10 milligram per 0.1, 20 milligram per 0.2 ml. So 0.2 ml, 20 milligram drug will be there. 0.2 ml means nearly 200 milligram. So for 200 milligram liquid, you will need about 600 milligram of adsorbent or so. You can make it free flowing to make your tablet powder, means tablet or capsule. In this way, what you are using mixed solvency concept to increase the drug loading in non-aqueous solvent system to develop the liquid solid system of poorly water soluble drug for their fast dissolution. Aqueous injection can be developed using the solvency concept, dry powder injection. This is another work, M4 project. All these are available online. Now coming to another application of mixed solvency concept, vaginal film have been developed using reduced, the size was reduced due to drug loading and enhancement by using this additive power, improvement of drug loading in ACDDS system to reduce the surfactant and co-surfactant concentration just by utilizing the solubilizing power of solids, improvement of drug loading in oral film to reduce Okay. Now, so now when in these oral film, insoluble drug loading has been increased and reducing the size. Then this is another work on fast dissolving oral film, reducing the size of the film, improving the drug loading using the solvency concept. Now, one more thing I would like to discuss here, a very interesting thing, that we can imply the solids for extraction. So very briefly, I will go. Here a published paper is there, eco-friendly extraction using solids in novel application of mixed solvency concept. And this is the published paper reference. It is available online. Okay, what has sesame oil as the active constituent, which is present in the sesame seed powder. Now, what we have tried that firstly, we have checked the solubility of our M4 student team. And of course, we have used this project for Indian patent we have applied. Thymol, 1 gram thymol in test tube, water bath, 50 degrees centigrade, it's a melting point, you will get clear colorless melted thymol liquid. In this, very good solubility of sesame oil was there, about 1 ml, very nice solubility. Then extraction was performed. Of course, whatever I am saying, it is not a refined work, but I am giving just an idea that how the solids can be employed for extraction of active constituent. So now the extraction, how it was done, 3 grams sesame seed powder, 9 gram, 3 times more, 9 gram thymol in test tube, water bath, 50 degrees centigrade, thymol melted liquid, 30 minutes shaking during melted condition, again heating, shaking and all that. During this shaking, melted thymol, dissolved sesame oil, which was present in the sesame seed powder, straining through cloth. Strained liquid was exposed to 60 to 70 degrees centigrade for the removal of thymol. Within 1 hour, nearly all thymol was removed. Some traces were there, and we were having sesame oil. Actually, so what? Just this is a brief idea that how the solids can also be employed for extraction. Another is menthol, similarly melted menthol, good solvent for sesame oil. Menthol 9 gram, 3 gram sesame seed powder, water bath, extraction, removal of menthol at 60-70 degrees centigrade. Third number, 50% weight by volume, thymol and ethanol. Ethanol is a weaker solvent for sesame oil. It was made a strong solvent using this solid solubilizing power of this thymol, 50%. This is very good solvent for sesame oil. And then 3 grams sesame seed powder, 9 ml of the solvent system, 30 minutes shaking, filtration, removal of ethanol and thymol at about 60-70 degrees centigrade, remaining was sesame. Anyway, those who are interested, please read this paper. And if you are have some doubt, please ask me, and I can give answer for your all queries. queries. Now coming to very good information for those who want to use all this mixed solvency concept and all this hydrotropy. I have made 7 YouTube videos. Each video is of 40 to 45 minutes duration. If you put these words, eco-friendly lecture series number 1, you will have this YouTube video, eco-friendly and economic UV spectrophotometric analysis of poorly water-soluble drugs by application of hydrotropy, mixed hydrotropy, and mixed solvency concept without the involvement of organic solvent. If you put these words, eco-friendly lecture series number 2, it is for UV analysis. No, so no, it is for titration analysis. And number 3 is for mixed solvency concept. Each and every substance, whether gas, liquid, or solid, present in this universe has got solubilizing power, mixed solvency concept. Eco-friendly lecture series number 4 is for TLC of the drugs. Number 5 is for reverse phase HPLC. Number 6 is for dry powder injection for reconstitution. Number 7 is to make innumerable eutectic liquids. This is also an art, very good art. Otherwise, from books, few eutectic liquids only you will get from the books, etc. But this YouTube video will help you to have innumerable eutectic liquids for extraction, for analysis, for synthesis, and all that. So like this. So now my lecture is over. Now I am coming to you. And of course, this is important thing for you, for those who are researchers who are interested for research work. They can see, they can note down my WhatsApp number. It is +91 94066219007. It is WhatsApp number. Email ID rkrkmaheshwari@yahoo.co.in. Okay. So now with this, my lecture is over.
Sir, thank you so much for giving a wonderful session in which by which student or many faculty members will learn so many things. During your presentation, sir, we got so many questions in chat box. Among them, I have taken some of them. So there is one question which has been asked by Pooja Bhavandar. She is asking, what are the maximum and minimum concentration of hydrotropic agent which can be used in formulation for the solubility study?
Okay, you see, there is no question of minimum concentration. Maximum, we can say maximum concentration. You should use such a concentration which is safe if you are making it a formulation as per inactive ingredient guide. As I have explained in my slide, it was for aqueous intramuscular injection. So in the same way, you can see different hydrotropic agents which are given in the inactive ingredient guide. You check. Actually, suppose sodium benzoate in inactive ingredient guide, several concentrations have been implied for different formulation. Some persons they have used 0.5%, some have used 1%, some have used 10% sodium benzoate in aqueous intramuscular injection. This means maximum concentration is this one, 10%. Don't use beyond this 10%. So from inactive ingredient guide, you select the concentrations of your hydrotropic agent, and definitely you should use mixed hydrotropic solubilization to develop the marketable formulation. This work from India in 2008, mixed solvency, this mixed hydrotropic solubilization. Papers were published, and Dr. Hussein Misri of Egypt, he used the same mixed solvency concept to mixed hydrotropic solubilization to develop the marketable formulation. Okay, so means there are so many persons who are using this mixed hydrotropic solubilization to develop the marketable formulation.
Thank you, sir. Thank you for giving a wonderful
one more. Let me clear one more thing. You see, more is the concentration of hydrotropic agent, more is the solubility achieved. So in this way, you should try a concentrated solution having say 25%, 20% or 30% concentration, so that you can achieve a good solubility like this. Okay, thank you.
Thank you. Thank you, sir. Our next question, which has been asked by the Rivaz, he is asking that how is gums on polysaccharides play their role in solubility enhancement of poorly water soluble drugs?
How
he is asking how polysaccharides molecules can play role.
Polysaccharide.
Polysaccharides.
You see, polysaccharide solutions, they are not so helpful in solubility enhancement. The reason is, you see, if you want to increase the aqueous solubility of some drug, By polysaccharides, what will happen? If your drug is water soluble, this means it is hydrophobic in character. And if you are using polysaccharides, they are polar type of compounds. For insoluble type of drugs, which are lipophilic in character, they require hydrophobic environment. For example, I am telling you examples. Sodium benzoate, how it is helping in solubilization? The reason is sodium benzoate, benzene, CONA is polar, benzene non-polar. When it is coming in solution, non-polar environment is there, which assists in weak van der Waals forces with the molecules of lipidic character of drugs, means insoluble type of drug. So, in the answer for your question is polysaccharides, they have got poor, you may say, solubilizing power for your insoluble drugs.
Thank you, sir. Thank you. So our next question, which is asked by the Nageshwar Rao, he is asking, can we use 10% of sodium benzoate as hydrotropic agent in RP HPLC analysis?
No, actually, you see, I think more than 4% or 5 or 6% solution, they should not be employed. The reason is, otherwise they will block, they will give harmful effect to the column. So concentrated solutions should not be employed. Of course, I am not expert of HPLC, but whatever I have learned from others, that higher than you may say 6% concentrations, they should not be employed. I will suggest that don't try for insoluble drug. You should select a water soluble drug so that you can employ 2% sodium benzoate, or 2% sodium benzoate plus 2% sodium citrate, or 3% sodium benzoate plus 2% urea, or something like mixed hydrotropic. They should be selected for water soluble drug. Do not select water insoluble drug. And in reverse with HPLC, in TLC, for each and every compound, TLC can be performed. If it is water soluble drug, you will require a higher concentration of hydrotropic agent. If it is water soluble drug, a smaller concentration, like this.
Thank you, sir. Thank you, sir. Our next question is asked by Indra Soneji. She is asking, can we use this solid solvent for extraction from plant material, and how?
Definitely we can use. You see, I will tell you one example. Number one, you should see my published paper. Number one, you please read it twice at least. Number two, now how can you imply the solubilizing power of solid? Always it is not required that you melt the solid, then you use for extraction. No, I am telling one example. Suppose your active constituent is having poor solubility in ethanol. And if you, because of this poor solubility, you're not able to extract out it using methanol, which is a safer type of organic solvent. So what you should do, you should potentiate the solubilizing power of this ethanol using solubilizing power of solids. For example, I'm giving some example. In the same way, you can think of other solids. For example, thiamol, if you are including 10% thiamol in ethanol, or 15% thiamol in ethanol, or 10% ethanol, in ethanol, 10% thiamol, 10% menthol, or 10% menthol, 10% camphor, like this. You make some blends in ethanol, and then you check the solubility of this active constituent, and if the solubility is enhanced sufficiently, suppose it is being enhanced by using 10%, say, thiamol and 10% camphor in ethanol. Use this solvent system, mixed solvent system, for the extraction of your active constituent. After extraction at room temperature, afterwards you will filter it out, and then you will remove the ethanol, thiamol, camphor by heating at about 60-70 degrees centigrade. And of course, if you want to recover these also, and then they are different things, but in this way you can thought of for this extraction using solubilizing power of solid. So many things are there. If you want really to do this such type of research, please connect with me on WhatsApp. I can give so many things, or I can give so many suggestions. But thing is, you will have to select the safe solids, economic solids, and so many things are there. It is not only thiamol, menthol, camphor. So many things they can be used. Vanillin can be implied. So many things can be done. Thank you.
Thank you, sir. Thank you, sir, for giving a wonderful reply again to this people who is working on a plant extract of plant derivatives molecules. Our next question is asked by the Rahul Vasist. He is asking, which solvent and combination of solvent is used for extracting amino acid, organic phosphoric acid, and free fatty acid existing in single material like wheat flour?
You see, this is a specific work. This I have not done actually. This they will have to be, means such studies should have been carried out. So be carried out. Then only we can say, because at this time, without seeing any solubility, I cannot say which solid cell we utilize further. But only thing will be trial and error. So best thing is for this I will have to think something. So you can take my WhatsApp number and tell me your exact problem. Then I will think and then I can give some suggestions to you. But definitely work can be done. No problem.
Sir, again, thank you very much for replying this question. So for the conclusion of vote of thanks, I will ask to my colleague. I request to Mr. Ankur Agrawal, sir, who is the convener and associate professor, Jai Institute of Pharmaceutical Science and Research, Gwalior, conclude the session and vote of thanks to everyone. Over to Mr. Ankur, sir.
Thank you, Rahul, sir. Thank you.
Sir, could you please, you are not that much audible. I think there is some voice issue.
Yes, sir. I am audible, sir. I am audible, sir.
Sir, it is not loudly. It is not loudly.
Yes. Yes. Okay. I am audible.
I think, Ankur, sir, there is some internet issue with it from your side. So if you allow, so then I can continue.
Hello.
Sorry for the technical glitch. I would request to Mr. Ankur Agrawal, sir, if you are having internet problem, please allow us, so then I can continue.
Hello. Hello, sir. Hello.
Okay, Ankur sir, thank you for joining with us. I think I need to take care of. Thank you.
Yes. Okay, sir.
As Dr. Mr. Ankur sir is having some technical issues, so I am going to conclude the session. To conclude the webinar, we would like to express our heartfelt gratitude to all our esteemed speakers, participants, and guests for joining us today. Your active engagement and insightful contribution have made this event truly enriching and valuable. Throughout the session, Professor Dr. R.K. Maheshwari sir have discussed the various subtopics such as drawbacks of organic solvent, different classes of solvents, limitations of eutectic mixture, eco-friendly trigonometric analysis of poorly water-soluble drugs, with example alternatives of organic solvent like sodium benzoate, sodium acetate, sodium citrate, chlorpheniramine maleate, etc. Methods to perform chemical analysis and pharmacopoeial method to perform HPLC and mixed solvency concept. We have gained a deeper understanding of the benefits and challenges associated with the using solid solvent and solid solvent mixture as greener alternative in various industries. The expertise and knowledge shared by our distinguished speaker, Professor R.K. Maheshwari, Dr. Sasi Alok sir, Mrs. Monica Sabharwal ma'am, and Mr. Ankur Agrawal sir, Dr. Saurabh Kaushik and Sanjay Nagbar, entire SPSR committee have been instrumental in shedding light on this cutting-edge approach and making this event successful. As we look forward to sustainable and environmentally conscious future, the insight gained from this webinar will undoubtedly serve as a stepping stone in shaping greener practices and reducing the environmental impact of chemical processes. We encourage all participants to continue the dialogues beyond this event, fostering collaboration and implementing the learning in their respective fields. Once again, thank you all for valuable contribution, and we hope to see you in future webinar as we continue to explore innovative solutions for a better world. Wishing you all success in your endeavor and have a great day. Thank you all.
Thank you. Thank you once again. Thank you.
Thank you, sir. Thank you, sir, for joining us.
Jai Shri Krishna.
Yes, yes,
May I leave?
yes, sir. Yes, sir. You can.
Okay. Okay. Okay.
Thank you, ma'am, for making you present an entire session